Yes, hello everyone. Yeah, in the afternoon class, we have discussed about the reasoning questions, right? And how to answer with the technical terms, right? And some of the properties of organic compounds, especially resonance effect or electromeric effect, through which we can explain the mechanism. These were the important points that we have gone through in the afternoon. Now it is about checking the order of the property. So usually the questions will be 3 compounds will be given and you are asked to find out the order of acidity or order of basicity, order of the boiling point, or so on. So basically they are all for reasoning questions only. They are all basically reasoning questions. If you know the reason, then only you can put it in that order. So we will go through such kind of questions and then we will go for other part of it, right? Now, yeah. Now, this is the predict the order of the reactivity of the following in SN1 reaction. In SN1 reaction. What is this SN1 reaction? As I told you, SN1 stands for substitution nucleophilic unimolecular, SN1. And the key thing to remember there is tertiary reacts faster than secondary than primary. This is a key thing you should remember immediately when we talk about SN1. Why tertiary? It is because the tertiary carbocation is the intermediate which is stable. Now, how to write the order? You have to understand what is the what about the molecule haloalkane? This is the carbon which is having bromine. This is having 2 carbon-carbon bonds. Better I will write like this. This is CH3, CH2, CHBr. This is CHBr, CH3. Now look at this. This is having 2 carbon-carbon bonds. That means this is secondary. It is secondary haloalkane. Now identify like this. This is a primary haloalkane because CH2, only 1 carbon-carbon bond is there. This is also primary. And this is easily you can find out. This carbon atom having bromine is having 3 alkyl groups. So it becomes easy now. Tertiary is having a higher tendency to undergo SN1 reaction. Predict the order of reactivity. Therefore, order of the reactivity is as follows. Tertiary first, then secondary. Then there are 2 primary. But in this primary, there is an alkyl group as a branch. Okay. If more alkyl groups are there as a branch, then inductive effect increases. Therefore, even though it is primary, having a branch here, this carbon atom is having a CH3 branch nearer to bromine that has got added effect. Then this. Therefore, this is the order of SN1 reaction. Now, second question. Arrange the following in the increasing order of acidic strength. Arrange in the increasing order of acidic strength. CH2ClCOH, CHCl2COH, CH3COH, CCl3COH. So you know that electron withdrawing group increases the acidity. Presence of electron withdrawing group. Chlorine is electron withdrawing group. CH3COH, CH3COH, acetic acid. Right? Now, if there is 1 chlorine, then it becomes CH2Cl, COOH, Cl here. So, presence of 1 electron withdrawing group, and if there is 2 electron withdrawing groups, then it increases further. Okay. So, there is 2 electron withdrawing group. There is only 1 electron withdrawing group. And in this, there is 3 electron withdrawing groups. So the key thing that you have to remember is electron withdrawing group increases the acidity of the compound. Therefore, the order is, you can think of, this is least, this is 1 chlorine atom with CH2, 2 chlorine atom and 3 chlorine atom, and one which is having 3 chlorine atom attached to the carbon next to COOH is having more acidic character. Now, arrange the following in the increasing order of boiling points. Boiling points is another thing. Butane 1-ol, N-pentane, butanol, ethoxyethane. So whenever such questions are being given, what you have to do is you have to write the structures of them, that is better. Butanol, CH3, CH2, CH2, CH2OH. This is butanol as an alcohol. Then comes N-pentane. This is CH3, CH2, 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 1, 2, 3, 4, 5. That means it is CH3. This is N-pentane. Butanol, but. So 4 carbon atoms and an aldehyde group because of all, aldehyde. And ethoxyethane, CH3, CH2, O, CH2, CH3. This is an ether. So there are 4 different class of compounds, of which the molecular mass is almost same, right? Now we have to compare the boiling point. As you know, whenever the boiling point comes, intermolecular force of attraction is the point to see. Intermolecular force of attraction. Now among this is having hydrogen bonding. Due to the presence of OH, there is hydrogen bonding. Hydrogen bonding is stronger intermolecular force of attraction. Then aldehyde group is having this carbonyl group, that is, this is having the charge separation as I discussed in the morning. This charge separation leads to a dipole moment. There exists strong dipole moment in aldehyde, right? Hydrogen bonding is the strongest among the dipole moments. So OH, if it is there, then it is having hydroxy group leads to hydrogen bonding, and aldehyde there is dipole moment. Ethoxyethane is having 1 oxygen atom. It can do a hydrogen bonding, or it can do hydrogen bonding, or it is polar, a little polar than this non-polar compound. Ethoxyethane is polar due to the oxygen carbon bond, and this is bent molecule. This is not a linear, bent molecule, and therefore there exists a smaller dipole here. So what is the order then? So ethanol is having highest boiling point, then comes aldehyde, then comes ether, and then next to that there is least one is pentane. Okay, so therefore this is the order. N-pentane is least, ethoxyethane, butanol, and butane 1-ol. So you can compare to the compare with the other kind of functional groups also, right? Okay. Arrange the following in the increasing order of basic strength. Increasing order of basic strength, commonly asked question, right? This is C2H5NH2, C2H5NH2, C2H5NH2. Okay, so this is base because of the pair of electrons, right? Because of the pair of electrons, and this donation ability depends upon its environment, ethyl group. Now comes C6H5, C6H5NH2, right? Aniline, then ammonia, and then C6H5 better to write it in this way: C6H5 CH2NH2 and C2H5 twice NH, secondary amines. Now basicity is to be compared always. This basicity is depend upon the environment or its surrounding, what is being attached. Now ethyl group 1 is there. Here in this there are two ethyl groups, and you know that basicity of secondary amines is more than primary amines, right? Okay, taking care of all the effect of hydrogen bonding and I effect. Okay, by considering both, secondary amines are having more basicity. So the arranged in increasing order, therefore the highest one is C2H5 twice NH. This is having highest. Then comes C2H5 NH2. Because these are alkyl amines which are more basic than ammonia itself. Ammonia and alkyl amines, when you compare, alkyl amines are more basic than ammonia. Because of the plus I effect, they are more basic. Now NH3 less is, among these two we have to compare. Now when you are comparing this, NH2 directly attached is having this effect. There is effect called plus R effect or resonance effect in aniline, therefore it is least basic. Therefore this comes next, that is C6H5CH2NH2, and then comes aniline. So that is the order. That is the order of basicity, and you may understood now. Okay, so C2H5NH, this is the highest one. This is the highest one. This is not in the increasing order, it is a decreasing order, right? Okay, C6H5CH2NH2. Okay, this is the order, and then NH3, then C6H5. Okay, confused a little. I will tell you once again. Okay, C2H5, this NH, secondary amines are more basic than primary amine. This is primary amine. This is secondary. This is primary amine, right? And then this is also alkyl amine only, alkyl amine. Therefore, it is more than NH3. This is also more than NH3 is an important point. So NH3 is having more than aryl amines. Aryl amines are having plus I effect, Sorry, aryl amines are having plus R effect, resonance effect, because of which it is least one. Okay, this is the way that you have to answer, right? Now the order of acidity and basicity and how to write the answers that you have seen. Now the another important part of the question paper is assertions and reasoning. We likely to do much mistake in this assertion and reasoning, right? So CBSE is following a pattern. CBSE is following a pattern in which the option A is always A and R both are correct, and R is the correct explanation of A. What we mean is there are two sentences, assertions and reason. Assertion is called A and reason is R, and these sentences A and R both are correct. First you have to find out that whether the sentence are correct or not, true or false. Then if R is the correct explanation of A, then choice should be A. If A and R both are correct, but R is not the correct explanation, R is not the correct explanation of A, reason is not correct explanation of assertion, then the option is B. Now, if A is correct and R is wrong, if A is correct, assertion is a correct sentence, but R is wrong, then option C is to be taken. And A is wrong and R is correct, then option D is to be selected. This is usually followed by CBSE for all the 9th to 12th examinations. The same ABCD pattern is followed. but don't have the same habit. Don't, without reading, don't choose the answer. In competitive examinations, the order is changed. Competitive examinations, the order A, B, C, D is changed. So they have to read oftenly and then come to answer that. That is one thing that I would like to tell you. So we are training based on the what the CBSE examinations are, right? And another thing is, in exemplar book, A, B, C, D, E is also there. Assertion and reason both are incorrect. That is another option in exemplar book, right? So we'll ignore that, and what is CBSE examination pattern, and we'll follow that, so that you are acquainted with the modalities, or how to attack the question, or how to find the answer to the question, right? Now KCN reacts with methyl chloride to give methyl isocyanide. Okay, KCN reacts with methyl chloride, CH3Cl, methyl chloride reacts with KCN to give methyl isocyanide. Isocyanide is NC. So this itself, okay, it is wrong because it is giving CH3CN. Okay, why this is confusing? Because there are two reagents, KCN and AgCN. KCN and AgCN. When it reacts with AgCN, it will give this compound. Therefore, directly you can say that, okay, directly you can say that this itself is, the assertion itself is wrong. So the answer is, okay, A is wrong. A is wrong, but R is correct statement. So that is the answer, right? Now coming to this, in monohaloarenes, further electrophilic substitution occurs at ortho-para position. In monohaloarenes, further electrophilic substitution occurs at ortho-para position. Monohaloarene means this is chlorobenzene ortho. Monohaloarene. Arene means benzene ring should be there, right? So this further substitution, electrophilic substitution, goes to either ortho or para position. So if chlorine is considered to be at one position, if the second position next to that is ortho, 1, 2 is ortho, 1, 4, if this is 1, then fourth, that is para. And you know that chlorobenzene is ortho-para directing. Therefore, if chlorobenzene already is there, if already present, chlorine already present in the benzene ring, then this has got a directing character. It directs to the, again, ortho and para position because of the resonance effect. So this is a true statement. Halogen atom is a ring deactivator. This is another thing in NCERT books, especially it is being given in the highlighted box, right? Chlorobenzene, this chlorine is a deactivator. What do you mean by this? There are two effects that you have to understand in the chlorobenzene. Okay, one is this chlorine is having lone pair of electrons, and it can give to the conjugation system. So this is called plus R effect. This is called plus R effect. It can do plus R effect. Thereby, it can activate the ortho and para position, electron rich. Electrophiles will be substituted there. That is one thing. Because of this first thing that going to happen, electrophilic substitution occurs. Chlorine being electron withdrawing group, the shared pair of electrons here, shared pair of electrons are being dragged to the chlorine because of electron withdrawing nature of chlorine. This is something contradictory to the one effect, that is, it is giving the electron in the to the conjugation system, but whenever the electron pair is shared, it drags towards it. Because of this, halogen atom is a ring deactivator. It is true. It is true. One more thing that I will tell you, phenol under mild condition undergo electrophilic substitution reaction. Phenol undergo very easily the electrophilic substitution reaction, but haloalkanes do not undergo with that condition. Therefore, it is a ring deactivator. Okay, it is being taken as a ring deactivator. So both assertions and Rita both are correct. Now, because of the halogen is ring deactivator, is it because of that it is directing orthopara position, which is not the correct thing? I mean, reason is not the right explanation of assertion. Reason is not the right explanation of assertion. Therefore, the truth is B. B is the answer for it, right? A and R both are correct statements, but R is not the right explanation of A, right? Now coming to the another question. It is difficult to replace the chlorine by OH in chlorobenzene in comparison to that of chloroethane. Read that. It is difficult to replace chlorine by OH in chlorobenzene in comparison to that of chloroethane. So there are two things to be compared. One is chlorobenzene, and then another one is chloroethane, CH3, CH2, Cl. Chlorobenzene and chloroethane, right? So it is difficult to replace chlorine. It is difficult to replace chlorine here, but this is easy to replace chlorine here. Is it a correct statement? Yes, it is a correct statement because it is having plus R effect. See, based on resonance effect, so many questions can be asked. Resonance effect is having double bond character. It can donate a pair of electron to form a carbon-chlorine bond is having double bond character, because of which it is strength of the bond increases so that it is difficult to remove chlorine. But whereas alkyl group and the chlorine, already minus psi effect of the chlorine is there, the bond is polar, easily can be cleavage. So that assertion is a right statement. Assertion is a right statement. Now chlorine carbon bond in chlorobenzene has a partial double bond character due to resonance. Due to resonance. So this is the exact answer to the assertion. Therefore, why it is so? Because of this is a double bond. This is not possible. Chlorine separation from chlorine cannot be replaced by OH. That means nucleophilic substitution reaction doesn't take place easily, right? So this is the correct explanation. Therefore, A and R both are correct, and R is the right explanation of assertion, right? So this is the thing. Now coming to the question like assertion, ethanol is a weaker acid than phenol. Ethanol is a weaker acid than phenol. Do you say it is correct or wrong? Ethanol, CH3, CH2OH, and phenol, which is more acidic? Why it is more acidic? This is being taken up. Phenol is more acidic. Phenol is more acidic because stability of the phenoxide ion. Phenoxide ion is stabilized by the resonance. Ethanol, it is not so. It is not stabilized. It is destabilized. Alkoxide ions are not stable. Alkoxide ion. This is forming alkoxide ion, that is ethoxide ion. Okay. This is ethoxide ion because already oxygen is negative charge, and this is alkyl groups also ready to give its electron, push its electron cloud towards it, therefore gets destabilized. Therefore, this assertion, ethanol is a weaker acid than phenol, is right thing. So you have to imagine all these things before coming to the conclusion that it is right or not. Okay, don't be in a hurry. Understand, write the structure and understand about it, and then do it. Sodium ethoxide may be prepared. Sodium ethoxide. Sodium ethoxide is CH3, CH2ONA. This can be prepared. This can be prepared by the reaction of ethanol, CH3, CH2OH, ethanol with NaOH. With NaOH. Okay, it looks like that the reaction may occur because we used to write all these things, OH and H2O goes away, and the product is CH3CH2 ONA. But it is not so. So ethanol doesn't react with sodium hydroxide because it is not that strong acid. If it is phenol, it reacts with NaOH. So this is the delicacy of the matter, right? So ethanol is not that much strong acid. If it is a phenol, that reacts with the sodium hydroxide to give sodium phenoxide. That is possible. But this is not the right answer. Therefore, reason is a wrong statement. Reason is a wrong statement. So if the reason is wrong, so this is C option to be taken. Right? Okay. Any other doubt, you can just type on that. Right? Okay. Responses. So put a message that your doubts and answers may be posted to the host, right? Those who are joining in Zoom Meet, you can give your response, right? Okay, so that I can see it. Now this arrangement is being made so that I can see the messages. In the morning session or in the afternoon session, there was some little problem with that arrangement. But now this is very clear. Now I can able to see the messages of you. If you have any doubt, we can able to answer then and there, right? Fine. Now assertion, formaldehyde is a planar molecule. Formaldehyde is a planar molecule. And it contains sp2 hybridized carbon atom. Okay. Formaldehyde, you have to recall that this is formaldehyde, the first thing. Then whether it is a planar molecule, for that you should know that, okay, this carbon atom, HCHO, this carbon atom is sp2 hybridized. Any sp2 hybridized carbon is moving trigonal planar nature. It will be trigonal planar. Therefore, assertion, reason, both are correct, and reason is the right explanation of assertion, right? So HCHO, right. One more. Aldehydes and ketones both react with Tollens reagent to form silver mirror. Aldehydes and ketones both react with Tollens reagent to form silver mirror. Both aldehydes and ketones contain carbonyl group. Can you able to think about it? Both aldehydes and ketones contain carbonyl group, C double bond O. So it is right. Second sentence is right. And we write like this, right? Ketones are written in this way. Aldehydes are written in this way. So this is the way that we write. Reason is right. But aldehydes and ketones both react with the Tollens reagent. That is the wrong thing. Only aldehydes react with Tollens reagent, but not the ketones. Therefore, what should be the answer? Okay, assertion is wrong. That is D is the answer, right? D is the wrong answer. A is wrong and R is correct statement, right? Acetanilide is less basic than aniline. Look at this. So what is very important is you should know the name, common name that is being used. Okay. We have to answer D, right? So answer D for Yanam has given an answer, that this answer D. Okay, for the previous question. Okay. Yes, thank you. Yanam school has given the response. Right. Now for this, acetanilide is less basic than aniline. What is the structure of acetanilide? Acetanilide is C6H5 CONH2. This is acetanilide. C6H5 CONH2. And aniline is this one. You know that NH2 is directly attached to benzene ring. This is aniline. This is acetanilide. Acetanilide is less basic. So I will write acetanilide in this way. C double bond O NH2, right? Sorry, I just this is not acetamide. Sorry, this is NHCOCH3, right? This is NHCOCH3. If I am cannot able to write here, I will write here acetanilide NH C double bond O CH3. This is product is obtained by acetylation of aniline, right? This is the product obtained by acetylation of aniline. This is aniline. This is acetanilide. For aniline, this is less basic because it can donate the pair of electron. Donate the pair of electron to the conjugation system. It cannot give the electron pair, therefore the basicity decreases. Aryl amines are having less basic. This is what the reason that we have given. But here in this case, there are two conjugation systems. One is conjugation system of benzene ring, and here again this is single bond and double bond, single bond, right? Single bond, double bond. Okay, this is conjugation system. This electron pair can be given to this side, to the benzene ring, or it can be given to the carbonyl carbon also. Therefore, once it is being given, this becomes single bond. C double bond O becomes C single bond O, and oxygen carry negative charge. Therefore, even less ability compared to this, acetanilide is less ability to donate the pair of electron because it is involved in two conjugation system, right? So this is acetanilide is less basic than aniline is the right answer, right statement. Acetylation of aniline results in decrease of electron density on nitrogen. Acetylation of aniline results in decrease of electron density on nitrogen. So this decreases also electron density because of acetylation. This decreases. Both are right on. Both are correct statements. And because of acetylation, acetanilide is less basic. Acetanilide is less basic than that aniline. Therefore, both are right statements. Both are right statements, and this is the right explanation of the assertion, right? Okay, fine. Okay, now moving on to another important topic, that is conversions, right? Conversions, basically one compound to another compound. How we do able to get that from one compound to another compound? Okay, so they will be giving the question like this. Okay, I will take up. They will be giving the question like this. How do you convert ethanamine to methanamine? Ethanamine to methanamine. Starting from ethanamine, how will you convert or get the methanamine? Okay, so these are the types of conversion questions, and they need the hold on reagents, right? It needs actually a hold on the different kinds of reagents. First of all, let me explain you the conversion in this way, so that it becomes more easier. You can the type of conversions are the conversions with ascending of series. If suppose the given compound and the product supposed to be get is the compound which is supposed to be got is having more carbon atom to be, then this is called ascending series. Descending series means the compound supposed to be obtained should have less number of carbon atom than the starting compound. Change of position, change of double bond or change of the OH, these are commonly propane 2-ol to propane 1-ol, propene bute 2-ene to bute 1-ene. All these things are the change of positions and others, right? So we'll take up basically how these are being done and which are the common reactions that we use for ascending of series. Descending of series, which are the reactions that we use. Let us try to make use of that, right? Now, in ascending of series, formaldehyde to propane 1-ol. Formaldehyde is having HCOH, right? Formaldehyde, sorry, it's HCHO. Formaldehyde, aldehyde, HCHO to propane, propane 1-ol. This is propane 1-ol. Formaldehyde to propane 1-ol. Ascending of series because one carbon atom to the 3 carbon atom. We have to add another 2 carbon atom, ascending of series. Acetaldehyde to propanol. Acetaldehyde, CH3CHO, and propane 2-ol, 3 carbon atom, prop. Word root prop means 3 carbon atom. These are all the examples of ascending of series, right? Let us see which are the reactions that we can use. So if more than one carbon atom is to be increased, more than one carbon atom is to be increased, and the starting one is aldehyde, then we can use Grignard reagent. The alkyl group in the Grignard reagent is added, and depending upon how many carbon atom is to be added, increased, we have to add that Grignard reagent. Therefore, if starting one is an aldehyde or a ketone, and if it is ascending series, remember the Grignard reagent. So this is the clue which serves whenever such questions are being given. Ethyl iodide to butane. Look at this kind of question. Chlorobenzene to biphenyl. Ethyl, 2 carbon atom. Butane, 4 carbon atom. So probably Wood's reaction. Number of carbon atoms will be doubled in the product. So 2 ethyl, 2 carbon atoms. Butane, 4 carbon atoms. Right? Now, acetaldehyde into crotonaldehyde. Acetaldehyde into crotonaldehyde. So but2-enol, but2-enol. Crotonaldehyde is common name, but2-enol. Okay, aldol, you know that. Aldol, when it is heated, you get enol. Therefore, here also in ascending series also we use aldol condensation. So for doubling the carbon atoms, we use Wood reaction and aldol condensation. Right. Benzene to benzoic acid, right? Benzene, C6H6, C6H5COOH, one more carbon atom added, right? Ethyl chloride to propanamine, propanamine. So for such reactions, sometimes we have to introduce CN, cyanide group, so that one carbon is added, right? So we have to go ahead for understanding how exactly we can able to do. Okay, we'll do how exactly we can able to do. Now coming to the formaldehyde into acetaldehyde into propane 2-ol. First, what you have to do is acetaldehyde. This is acetaldehyde, right? Or more clearly, is it visible? Okay, this is acetaldehyde. Sorry, it's gone ahead. Yeah, acetaldehyde into propane 2-ol. Acetaldehyde is CH3COH. This is acetaldehyde. And what we need is propane 2-ol. Propane 2-ol. Okay. I think I have to take up formaldehyde into propane 1-ol. Okay. Some problem with the sliding of that. So first question that I would like to take is formaldehyde to propane 1-ol, right? So formaldehyde I will write in this way, formaldehyde. And propane 1-ol. Propane 1-ol is CH3, CH2, CH2OH, right? This is propane 1-ol. Right. So we need to introduce two carbon atoms, right? So choose the suitable Grignard reagent. Okay, to get that, we'll go like this: CH3, CH2, MgBr. This is ethyl magnesium bromide. This we have to use. Whenever you use this, alkyl group will be attached to this and MgBr to the oxygen. So that initially this carbon having two hydrogen will remain as it is, and this O will be get added by MgBr, and alkyl group CH2, CH3 is attached to carbon. Okay. So when this is being added, then this on hydrolysis will give alcohol. H. Okay, on hydrolysis will give alcohol. CH3, CH2, CH2OH. CH3, CH2, CH2OH. This is being obtained. Another compound which will be obtained is MgOH-Br. Magnesium hydroxy bromide. You need not write about this. Okay. Okay. Right. Now coming to the another one, acetaldehyde to propane to all. Acetaldehyde to propane to all. Here also, depending upon what is the necessity, that we have to add the Grignard reagent. Right. So two carbon atoms are there. Two carbon atoms. Okay. This is the skeleton already is there. This skeleton. Compare this skeleton. Okay. So one more CH3 is to be added. Therefore, CH3MgBr, methyl magnesium bromide. So as usually, alkyl group will go to carbon and MgBr to the oxygen. This mechanism you remember. CH3, CH, this is CH3 attached one from the Grignard reagent, and this O will become OH. Okay, OMgBr, right? This OMgBr, this upon hydrolysis will give you CH3, CHOH, CH3. CH3, CHOH, CH3. This is not CH2. Okay. Okay, this we cannot rub that. That's the problem. This CH. Okay. So formaldehyde over propanol. This is the way that Grignard reagent, using Grignard reagent we can do. Now coming to okay. Now coming to this acetone to tertiary butyl alcohol. Acetone. This is acetone, right? Common name, acetone. To tertiary butyl alcohol. Tertiary butyl alcohol is, the structure is like this. This is tertiary butyl alcohol, again common name. These are all given in common name. These are widely used, right? Therefore, you should know about the common name associated with the structures and formula of the compound and so on. Now again, see this skeleton. This skeleton already it is there in the compound. This is what to be observed. What is extra? One CH3 is to be added. So which is the Grignard reagent to be taken? So it is naturally that this is methyl magnesium halide, chloride or bromide, right? This is to be chosen. And again, the intermediate will be CH3. This carbon atom, this methyl group will be attached. This methyl group. Then OMgBr. Okay. So on hydrolysis, it will give this product. Okay. So remember, one important thing, it is, if it is formaldehyde is the starting material, formaldehyde, the alcohol obtained after treating with Grignard reagent is always primary alcohol. For getting primary alcohol, we start with the starting material should be formaldehyde. And for getting secondary alcohol, the starting material is aldehyde other than formaldehyde. For aldehyde other than formaldehyde with Grignard reagent will give secondary alcohol. And Tertiary alcohol is obtained by ketone. Any ketone you take. Starting material, carbonyl compound should be ketone, and with the Grignard reagent will give tertiary alcohol. Okay, so this is the thing that you have to remember, right? Ethyl iodide to butane. Ethyl iodide, CH3CH2I. Ethyl iodide to butane. CH3CH2CH2CH3. This is butane. Ethyl iodide to butane, right? Now, this is a simple one because you have to add sodium in ether, and if necessary, then you may write that is a Wood reaction. Okay, two alkyl groups, this is needed, 2Na plus 2NaI. Other product. Minor product you need not bother, but get what is the product required from what is the starting material, right? So this is Wood reaction. 2 carbon atoms to 4 carbon atom, or the 2 carbon atom compound is a halide, then Wood reaction is being used. Okay, fine. Chlorobenzene to biphenyl. The question is difficult because what is the structure of biphenyl? Otherwise, it is easy. The biphenyl compound consisting of 2 benzene ring. This is biphenyl. Okay, so the chlorobenzene is this. Okay, when you write these structures, the question answering will become easy. Therefore, structure has got its importance. Okay, to write the structure of the compounds. Now this with sodium. Okay, with sodium, 2 alkyl groups are added. Where the chlorine bond is there, carbon-chlorine bond is there, it becomes carbon-carbon bond. So this is Fittig reaction. It is called Fittig reaction, right? It is possible. Now, acetaldehyde to crotonaldehyde. Acetaldehyde is here. Acetaldehyde. Crotonaldehyde is but to in, this is double bond, and al. Okay, but to in al. But to 1, 2, 3, 4. Okay. CHO. Okay. So but to enal. 1 carbon, second carbon, 3 carbon, fourth carbon. So second carbon, there is ene, and first carbon atom aldehyde. Therefore, it is but to enal. But to enal. How to convert this? So first thing, that clue that you have to go with is 2 carbon atoms to 4 carbon atoms. 2 carbon atoms to 4 carbon atoms. Okay, whenever this is doubled, right? So either Wood reaction you have to think of, or another thing to be thought of is aldol condensation. Okay, if the starting one is an aldehyde, then there is a more chance of having aldol condensation. Now CH3CHO undergo aldol condensation in the presence of NaOH. Okay, how this aldol condensation takes place? CH3CHO, this is one molecule. Another molecule is CH3CHO. This hydrogen, which is acidic next to the aldehyde group, okay, this hydrogen is given to the first molecule. This hydrogen, acidic hydrogen, is given to oxygen, right? Therefore, this is CH3CHOH, CH3CHOH, one which is added, and the carbon to which that O is attached, for that another molecule also get attached. This molecule get attached to the carbon, so that we get a compound with aldehyde group and alcohol, 2 functional groups. So this is aldol. It is called aldol. Aldehyde and alcohol both are there. Aldol. So aldol, further prove that this hydrogen is acidic next to the CHO is acidic. After heating, this H and OH eliminates as H2O, creating a double bond here. Therefore, simply heating this aldol is needed so that we get enol. Okay. Therefore, acetaldehyde to crotonaldehyde is the conversion can be done by making the compound to undergo aldol condensation in the presence of sodium hydroxide. Then heating further will give this product. Benzene to benzoic acid. Always first try to write the structure of this. Benzene to benzoic acid. Okay. So benzene to benzoic acid. So you have to do a carbon-carbon bond. Probably you have to do alkylation. Alkylation can be done by adding CH3Cl and AlCl3. This is called Friedel-Crafts alkylation. Friedel-Crafts alkylation need a Lewis acid like AlCl3, which helps in generation of electrophile CH3+. So this adds up CH3 to the benzene ring. Okay. Friedel-Crafts alkylation. When alkyl group is there, then you can convert this into COH by adding KMNO4 KOH. KMNO4 KOH. Alkaline KMNO4. Okay. So it is an oxidizing agent which oxidizes alkyl groups attached to the benzene ring to benzoic acid. Right? So this reagent is helpful in the conversion. Therefore, remember this. So benzene to benzoic acid having only one intermediate. Right? Ethyl chloride to propanamine. Ethyl chloride. CH3, CH2, Cl. Ethyl chloride to propanamine. CH3, CH2, CH2, NH2. This is propanamine. Ethyl chloride to propanamine. So you can see one carbon atom is increased. Ascending series, one carbon atom is increased. Somewhere there is a need of introduction of cyanide group. So introduction of CN helps in having one more carbon atom to the added, one more carbon atom added to the present alkyl group. Therefore, you know that nucleophilic substitution reaction, alkyl halide with KCN will give CH3, CH2, CN. CN, right? So this can be, this C triple bond N, this can be reduced, CH2, this becomes CH2, two hydrogen added and two hydrogen added for nitrogen both can be done by adding lithium aluminium hydride. Lithium aluminium hydride is a reducing agent, right? So reducing agent is lithium aluminium hydride so that we get propanamine, right? So ethyl chloride to propanamine, okay? Okay. So these were the ascending series. What are the points that you carry? How to convert the compound which is having more number of carbon atom than the parent compound given. So this is called ascending series. So remember the 4-5 reactions that is the come in the way for ascending series. One is Grignard reagent, use of Grignard reagent. Any number of carbon atom can be increased by using Grignard reagent. So it should be aldehyde, starting material should be aldehyde, right? Then Wurtz reaction. Wurtz reaction multiplies the number of carbon atoms into 2, all right? And then introduction of CN. Introduction of CN also will help in ascending of series kind of question, all right? And aldol condensation, all these are the reactions which we may use for doing the conversions. Now, descending of series. In descending of series, propanoic acid into ethane. Prop, 3 carbon atoms into 2 carbon atoms. Propanoic acid into ethanamine, different class of compound. And ethanamine to methanamine also. So these are all the examples of descending of series. Let us take one by one. Propanoic acid to ethane. Propanoic acid to ethane. Okay, propanoic acid to ethane, right? Propanoic acid is having 3 carbon atoms and ethane is 2 carbon atom, hydrocarbon. So here we have to remove that COH. This is called decarboxylation. Decarboxylation reaction. So decarboxylation reaction, the reagent needed is NaOH in the presence of calcium oxide. So it is in the 11th class also. So to get the preparation of alkanes, we have studied about it. Soda lime, it is called soda lime, right? In the presence of CaO, NaOH, it reacts with NaOH to give an alkane, right? So this is the decarboxylation reaction. Okay. All right. Now coming to another one. Okay, propanoic acid to ethanamine. Okay, propanoic acid to ethanamine. Propanoic acid to ethanamine, CH3, CH2, ethanamine, CH3, CH2, NH2. Okay, so this is important. So here, the 3 carbon atom is to be reduced to 2 carbon atom, right? By removal of COH, we will get ethane. Okay, number of carbon atom is reduced. But remember that once you get into ethane, ethane will be very less reactive. Hydrocarbons are less reactive, right? Therefore, you cannot further change. It will be difficult. So what is the change that we can make? So we can use Hoffman's bromide degradation. Hoffman's bromide degradation, you know that Hoffman's bromide degradation can be done if CH3, CH2, CONH2, if this is the compound, you can able to get from this compound to this compound. Because CO is being removed from propanamide, you can able to get ethanamine. Propanamide to ethanamine is possible. So what is the reagent? Hoffman's bromide degradation, NaOH plus Br2. NaOH plus Br2. Right? Therefore, this is the step that we have to use. So remember that we need not start from this material. Okay, we can have the sequence like this also. From this compound, we can able to get the last product. And how we can get this from propanoic acid? Okay, so this is CH3, CH2, CONH2. This amide from carboxylic acid is obtained by treating with ammonia and heat. Ammonia, when you add ammonia, this will be forming CH3, CH2, COO minus and NH4 plus. Okay, so ammonium ion and a carboxylate ion, an ionic compound is being formed, right? When ammonia reacts with carboxylic acid. So upon heating, this H2O will go, so that CO and NH2 will remain. So that an amide is obtained by treating a carboxylic acid with ammonia and further heating that. So you can make the sequence like this, so that from propanoic acid, ethanamine is obtained. So Hoffman's bromide degradation is the one reaction which is used for descending of series, right? Decarboxylation, removal of COOH group by using NaOH and CaO, that is soda lime. And the second reaction, another reaction is amide. Another reaction is Hoffman's bromide degradation, amide to amine. Usually, if one carbon atom is less, then these are the likely to be used, right? Now, ethanamine to methanamine. Ethanamine, CH3, CH2, NH2. Ethanamine to methanamine, CH3, NH2. Okay, so this is the one which having several steps, right? Okay, you may think of how to take up this question. Okay, as I told you, this can be obtained from. Okay, we'll have the steps like this, right? How this compound can be obtained? If at all we have to use Hoffman's bromide degradation, then ethanamide we have to use, right? CH3, CONH2 we have to use. And this CO is removed by NaOH Br2, correct? So this reagent, NaOH Br2, Hoffman's bromide degradation takes place, right? Okay. Hoffman's bromide degradation takes place from this. Now, the one which is that we can obtain, this one is, as we have seen, an amide can be obtained from carboxylic acid. Can you tell me which carboxylic acid from which this can be done? This is ethanoic acid. From ethanoic acid, you can able to do. This is by NH3 and heat. Amide is obtained. NH3 by heat, just as the last question that we have taken. Now, how to get carboxylic acid? This can be got from CH3, CH2OH. CH3, CH2OH, ethanol on oxidation. So for oxidation, you need KMnO4, H2SO4, right? KMnO4 plus H2SO4 is strong oxidizing agent, converts ethanol into ethanoic acid. Therefore, this can be used. Now, how to get ethanol from ethanamine? This is a typical reagent, that is HNO2, nitrous acid. Nitrous acid, when you use aniline nitrous acid, you find the stable diazonium salt. But if it is an alkyl amine, HNO2 results into alcohol. Okay, whatever may be the temperature, if it is 0 degrees Celsius also, it will form alcohol only. But 0 to 5 degrees Celsius, diazonium salt. If it is benzene ring is there, it is stabilized by the resonance, therefore it will be stable. But here it is alcohol. Okay, now consolidate amine to alcohol, alcohol to carboxylic acid, carboxylic acid to amide, then amide to amine. Okay, so this may contain several steps, but if you have a logic, then you can able to do this conversion easily, right? Right, change of positions. How it can be done? Change of positions. Let us take the examples, right? 2 bromopropane into 1 bromopropane. 2 bromopropane. 2 bromopropane into 1 bromopropane. Okay. So here, what the trick that we have to use it? So we have to make double bond as an intermediate, right? So intermediate in the sense, It is not a unstable, but the compound which is from which it is being done normally for change of position. So you have to use dehydrohalogenating agent. Dehydrohalogen agent, that is removal of Br and one of the H. Dehydrohalogenation. So this is done by alcoholic KOH. Alcoholic KOH is dehydrohalogenating agent. So this will give you CH3, CH, double bond, CH2. Right? CH3, CH, double bond, CH2. If the compound Br you have to use, okay, so we have to add H and Br. H here and Br here. But if you simply write HBr, will it happen? So there is a Markovnikov's addition and anti-Markovnikov addition will come to the play. What is Markovnikov addition? Markovnikov addition is negative part of the addendum will go to that carbon atom which is having least number of hydrogen. Therefore, bromine will come to this carbon atom and it is the same compound from which we have started. Therefore, simply adding HBr will not solve the problem. We have to do anti-Markovnikov addition. Therefore, we have to add peroxide. HBr peroxide will give anti-Markovnikov addition. You may write here also anti-Markovnikov addition, and Br will be added here and H will be added. So every reagent that you write is important. So you have to mention. If you are not mentioning peroxide, then marks will be cut, right? So that the position, change of position, this technique that you can employ, right? Okay. Okay. Propane 2-ol to propane 1-ol. Propane 2-ol. Propane 2-ol to propane 1-ol. Propane 2-ol to propane 1-ol. Right. Now this, again, we have to go for an alkene as the one which is coming in between. Right? Right. So this, what is the one which you are going to use? If you want to convert this double bond, right? OH and H goes away. So this is nothing but dehydration. So here we have to use concentrated sulfuric acid. What is that? Concentrated sulfuric acid. Use concentrated sulfuric acid so that this converts into an alkene. Right. Now again OH is to be added. Okay. So if you do acid catalyzed hydration, again propane 2-ol is obtained. For the propane 1-ol, there is one method called B2H6 or BH3 plus H2O2. So this is called boration and oxidation. So this is hydroboration and oxidation. So this works as if it is undergoing anti-Markovnikov addition. OH will be there to the first carbon atom. So important, very important. Suppose if you add acid catalyzed hydration, you are going to get CH3, CHOH and CH3. Here we don't say that it is a Markovnikov addition, but this works as if the Markovnikov addition is happening. This works as if anti-Markovnikov addition is happening. So if the OH is to be in the middle carbon atom, you use H plus and H2O, and B2H6 hydroboration and oxidation, H2O2. Hydroboration and oxidation can be done so that propane 1-ol is obtained. Right? These are the important hints to be remembered. Okay. Now, propane 1-ol, CH3 CH2 CHOH. Oh, this is rather easy. Propane 2-ol. I think you can able to do. I think it is easier one. Again, concentrated H2SO4, almost the things required I have told. So that this is HOH goes away, double bond CH2, right? Propene is obtained. Then propene to this, as I told you, this is H plus H2O. Acid, hydration of alkene, acid catalyzed hydration. Acid catalyzed hydration will give propane 2-ol. Okay, so the reagent that you should use should be carefully done here. Okay, so this ability they are going to ask there. Okay, it's not working. So any other type, let us know. Benzene to aniline, phenol to salicylic acid, chlorobenzene to benzoic acid. Let us try to know about it. Benzene to aniline. Okay. I will just and show is not coming. Yeah. Okay, it's not working sometime. Okay. Okay. Benzene to aniline. Aniline, this should be okay. Benzene to aniline. Okay. Now we have to introduce carbon and nitrogen bond. Sometimes students do the mistake of NH3, he will add NH3. It is not NH3 to be added. So it needs to be done through NO2, nitrobenzene. How do you convert benzene into nitrobenzene? So benzene to nitrobenzene can be done by concentrated HNO3 plus concentrated H2SO4. Mixture of concentrated HNO3 and concentrated H2SO4 is called nitrating mixture. Nitrating mixture that develops NO2 plus as an electrophile, NO2 plus electrophile, and then electrophilic substitution takes place to the benzene ring. So nitration occurs to the benzene ring. So concentrated HNO3, concentrated H2SO4. This is to be reduced. Oxygen is to be removed and hydrogen is to be done. For that, you need SN plus HCl. This is the reagent. SnHCl, FeHCl are the reagents, right? So in the preparation of aniline, we have studied this from nitro compound to aniline. So through NO2, you can able to get it, right? Okay. Phenol to salicylic acid. Phenol. Salicylic acid. So sometime common name will be given, and this is OH and COOH. Phenol to salicylic acid. 2-hydroxybenzoic acid is salicylic acid. This is studied in the named reaction also. This is Kolb's reaction, right? Kolb's reaction. First, we have to add NaOH so that sodium phenoxide is being formed. Sodium phenoxide further reacts with CO2, carbon dioxide, right? In the presence of H plus. So the reaction CO2 will abstract hydrogen from the ortho position and it becomes COOH there. And this, for this again, acidification is needed. Whatever, in the conversion, if you write this much also, it is enough. So phenol to sodium phenoxide, sodium phenol to salicylic acid is possible by addition of CO2, right? So this is a conversion and also is a named reaction, right? Chlorobenzene to benzoic acid, chlorobenzene to benzoic acid, chlorobenzene to benzoic acid. Okay, so this is a typical one, typical conversion, because carbon chlorine bond is having double bond character and you cannot remove that so easily, right? So we have to remove this carbon chlorine bond and we have to create carbon carbon bond, right? Carbon carbon bond. So these are the essential thing. For that, the clue is, if this is to be made react with magnesium in ether, we get phenyl magnesium chloride. We are getting phenyl magnesium chloride. Phenyl magnesium chloride, right? Chlorobenzene to magnesium and ether, it gets phenyl magnesium chloride. Phenyl magnesium chloride reacts with carbon dioxide. I write like this, carbon dioxide, because, and upon hydrolysis, it will give benzoic acid. That COO comes like this. This phenyl group is added to carbon, right? The phenyl group is added to carbon. One double bond O will be here and another O, this MgBr is added. MgBr is added. So carbon alkyl group or aryl group is added and MgBr, one oxygen MgBr. And this upon hydrolysis, the MgBr will go away and forms OH. So C6H5COOH. So the reagent is, chlorobenzene is to be converted into Grignard reagent, and Grignard reagent with CO2, carbon dioxide, will give benzoic acid, right? Okay, now, so these are these are the questions from conversion. So as many as questions possible you have to do conversion. In some reference books, appendix is being given at the last pages. About 100 to 200 conversions are being given. You can just go through that one by one. You will get hold of the reagents that can be used, right? So it is all logic based, okay? And the reaction conditions required for each reaction need not be written there, but the reagent used from one compound to another compound to be written correctly. So that is expected, right? Now another trend is word problems or ABC type questions. Let us see which are the questions which are being asked here. Okay. An organic compound X having molecular formula C4H8O gives orange red precipitate with 2,4-DNP reagent, does not reduce Tollens reagent, but gives yellow PPT of iodoform on heating with NaOI. Compound X on reduction with lithium aluminum hydride gives the compound Y, which undergoes dehydration reaction on heating with concentrated sulfuric acid to form butene. Identify the compound X and Y and explain the reactions. This is the trend. This is a trending question in CBSE examinations. One question for either 3 marks or 5 marks are being given, right? So how to attack or how to write this answer to this? First, you have to make some skeletal impact. What I mean is, say there is X, compound X you have to write. Its molecular formula is being given C4H8O. Okay, this gives orange red precipitate with 2,4-DNP. With 2,4-DNP, it gives orange red precipitate. Orange red PPT. That means it will answer 2,4-DNP, right? So if a compound is answering 2,4-DNP, 2,4-dinitrophenylhydrazine. So this is the reagent. This reacts with only aldehydes or ketones, right? So very important thing, 2,4-DNP. While distinguishing test also I told about it. But more than that, here we use that in word problems. A compound which is giving orange red precipitate with the 2,4-DNP is either aldehyde or ketone. This is the one clue that we'll get from the first information which is being given. The second question is, it does not reduce Tollens reagent. That means Tollens reagent, it won't answer. It is not X, but it won't give. Okay, some mark that you can make. It won't give the reaction. Okay. Now, it is also another clue. If it is not giving the reaction, also is a clue. First clue is about it reacts with 2,4-DNP. We can conclude that the compound may be either aldehyde or a ketone. It doesn't react with Tollens reagent means what? It must be a ketone, because Tollens reagent, one which reacts with is an aldehyde. It doesn't react means it must be a ketone. See, this is the impress that these two imply that X should be an aldehyde. Sorry, a ketone. Okay, it's not working. A ketone. X should be a ketone. This is the way you can write. Don't think that you should write everything. You should do it in the rough work. But it is for these reactions, for such questions, you should write. This is the way of answering. So these two clues implies that X should be a ketone. Now let us go for another clues. Another thing that is being given. So the doesn't reduce Tollens reagent, but gives yellow PPT of iodoform on heating with NaOI. Yellow PPT, that is iodoform test. So X gives iodoform test. This is NaOI, okay, NaOI or NaOH plus I2. Both are same. NaOH reacts with I2 to give NaOI. Therefore, it may be written in this way. X reacts with NaOI to give CHI3 iodoform. What do you imply? What it implies? That means X is containing skeleton CH3CO. It must be 2 ketone. So first clue tells that it is a ketone, and the second clue tells that it must have CH3CO, because only the compounds which is having CH3CO, 2 ketones, second carbon atom having carbonyl group, will answer iodoform test. Then, so X on reduction with lithium aluminum hydride produce Y. X on reduction, it will give Y. And Y undergoes dehydration reaction on heating with concentrated sulfuric acid to give butene. So there are two reactions. One is X undergo on reduction with lithium aluminum hydride, it will give Y. Then Y which undergoes dehydration reaction to give dehydration. On dehydration, it gives butene. I will write like this: CH3, CH double bond, CH, CH3. This is butene, right? So on dehydration, it will give butene. That means If any compound undergo dehydration, then it should contain same number of carbon atom. Dehydration is removal of OH and H, and therefore this should have 4 carbon atom. That is one clue, right? CH, CH, CH3. So dehydration, probably this is OH, this contains OH, and this contains one more H. So Y is an alcohol. So OH and H removed means there will be double bond, butene, right? So if Y is a double bond and it must be an aldehyde, that means it must be CH3CO, CH2, CH3. So this is propane to one. It should be propane to one. Whether it matches with the formula given, let us try. So this is C4, 1, 2, 3, 4 carbon atom. H8, 3 plus 2 plus 3, 5 plus 3, 8, and 1 oxygen. So it matches. So tally at the end whether it matches or not, right? So, and all the reactions can be written. So you should go with clues, right? So it is a good question. Okay. Okay. Now, a compound X C2H4, C2H4O on oxidation gives Y, and X undergoes hollow form reaction on treatment with HCN. X form the product Z, which on hydrolysis gives 2-hydroxypropanoic acid. Write down the structure of X and Y. Name the product when X reacts with dilute NaOH. Write down the equation of the reaction involved. Such kind of questions are much more likely in the examination. The X, okay, I think you can able to do more easily now. On oxidation will give Y C2H4O2, C2H4O, and X undergo halo form reaction. Halo form reaction means, again, this should have this skeleton. Halo form reaction. This is iodoform reaction. With iodine, it undergo iodoform reaction. This should have this clue. And on treatment with HCN, X forms the product Z, which on hydrolysis gives 2-hydroxypropanoic acid. Okay. So this is more clear now. C2H4O must be of this kind, CH2, CH3. C2H4, sorry. So C2H4O on oxidation gives Y. X undergoes hollow form reaction. So hollow form reaction, and it should contain 4 hydrogen, means it should be an aldehyde like this, CH3. 2 carbon atom, 4 hydrogen, and 1 oxygen. So on oxidation, it will give CH3COOH. Aldehyde gives this. So that C2H4O2, right? This is a structure of aldehyde X, and the Y is this structure of Y is being written. Name the product when the X reacts with the dilute NaOH. When reacts with the dilute NaOH, aldol condensation takes place. Therefore, CH3, CHOH, CH2, CH3. This results, aldol results when it reacts with NaOH. This we can write, and write down the equations of the reaction involved. All that reactions involved you can able to write. So it is not very difficult. Okay, it is not very difficult, but writing stepwise, okay, makes it easy, right? So at the end we'll take up the question, right? Oh, this is the CBSE from this year CBSE sample paper. An organic compound with molecular formula C7H7NO2 exists in the 3 isomeric form. The isomer A has the highest melting point. See the way that it is being given. So the molecular formula C7H7NO2. C7H7NO2. Okay, 3 isomers are possible for this, it is being told. Therefore, okay. Hello. Okay. So this is A is reduction with the compound B, and B with the molecular formula C7H9N. B on treatment with NaNO2HCl. Of course, this is having a lot of steps to do, as the time is getting over. You may take the screenshot and try. Tomorrow morning, when we have come back, we will discuss this paper in detail, this question in detail, because we have to study the examiner's mind. Such questions are likely. This is the one question which is asked for 5 mark. 5 mark in the latest CBSE sample paper 2023-24, right? So this question can be discussed more in length tomorrow. Okay, anything to ask? Somebody's mic is on. You can ask if there is anything to ask. Otherwise, meet you tomorrow. Thank you. Tomorrow I will take up once again this question and also some objective type questions in the organic chemistry, right? Okay.